This is lab report 5, elastic versus inelastic collision. And so for this lab, the goal is to analyze the elastic collision of two bowling balls and the inelastic collision of a car crash test. And this is to show that momentum and or kinetic energy is conserved in elastic collisions, while in inelastic collisions, momentum and or kinetic energy is lost. And so a preview for the results. So the collisions largely follow fundamental principles, but show that perfect collisions are not possible in nature. And so for the fundamental principles, so the two fundamental principles are impulse and momentum and then energy. And then in energy, that's sort of the umbrella for change in energy and also collisions, which is the focus of this lab. And so the two main equations utilized in this lab are impulse, which is equal to the change in momentum, and then also for kinetic energy. So for the elastic collision, initial conditions and assumptions. So the system is the bowling balls and the string, and then the surroundings is the rest of the universe. And it's assumed that the initial velocity for both bowling balls is 0. And then the mass of the bowling balls is 5.9 kilograms, which is just the average of the range that regulation bowling balls tend to be. And then also for the diameter, that's also an estimate, which is about 0.2 meters. And then it's assumed that the mass of strings are negligible in the motion. And then also for the tracker analysis, the origin is at the center of the initially motionless bowling ball. This is the video for the collision. Okay. So for the tracker data, so as you can see by these graphs, the graphs are there. First of all, it's sinusoidal because it's an oscillatory motion. And so when you look at the motion of the graphs, they're near complete opposites of each other, which indicates that there was a transfer of kinetic energy, which matches with what an elastic collision does. And so for the average velocity, so these are all magnitudes. So for the first period, this is just the velocity of ball 1, while this is at 0. And then there's that transfer that happens. So now this has an average velocity, and this one just goes to 0, and then up until 1.93 seconds. And then there's another transfer, which leads to this one back to having kinetic energy, while this one goes back to having no kinetic energy. And which is indicated by this table, which calculates based upon the average velocity. So this one's 2.6, this one's 0. The transfer happens, this is now 2.5, and then 1.9 is oscillatory. It's gonna go back. It doesn't stay consistent because it's oscillatory, so it'll stop and then go back. And then there's another transfer, and then now this one's 2.2, and this one's about 1.9, and while this one becomes 0 again. As for the other collision, the inelastic collision, so the system is the car and the wall, and then the surroundings is the rest of the universe. And then the initial velocity, about 22 meters per second, and then the mass is close to 1,600 kilograms. And then it's assumed that the friction of the surface that the car is traveling on is negligible. So the only force in this motion is the contact force exerted by the wall during the collision. And this is the video. And so for the time of the collision, so the video itself was about 2 seconds long, but actual collision was only about 0.4 seconds. So then for the initial momentum, it's about 35,000 kilograms per meter per second, and then the final momentum becomes 0. And so basically the impulse is just equal to the negative change in the momentum, and then the magnitude of the force was 80,000 newtons. And then for the initial kinetic energy, it was about 383,000 joules, but then the final was 0. And so for this lab, do perfectly inelastic or elastic collisions exist? So in terms of real or experimental collisions, perfectly elastic or perfectly inelastic collisions do not exist. So during the elastic collision, the total kinetic energy of the system will go down slightly, which indicates there's some loss. So it's probably due to thermal energy, another type of energy loss. And then for the car crash test, the final velocity becomes 0, but you could see through the video that there was actually a rebound. So the final velocity didn't actually become 0 until later on throughout the video, which means that the inelastic collision actually partially resembled an elastic collision. And so to conclude, there's a clear distinction between elastic and inelastic collisions even in real circumstances, but real collisions are not perfectly elastic or inelastic, but they rather on a spectrum in which a collision would lead towards one or the other. And as for error, so while there's likely error from the tracker analysis itself, there's a big enough discrepancy in differences between kinetic energies in the bowling ball collision to indicate that it's not perfectly elastic. Thank you for watching.